Principles of Biomedical Science students, and welcome to another wonderful walkthrough with me, Miss Ayat. So as always, I start in the 1A Principles of Biomedical Science stream. Click from stream over to classwork. And we're going to do the assignment for Monday, 11/23 for my A-Day classes, or Tuesday, 11/24 for my Block 1B. So open up 1.2.4 Lab Journal. And I already made a copy because I'm thinking ahead. And now log into my PLTW, okay, with your username and password. Pause it if you need to. So here I am logging in, which it logged me out. And you click on Courses. And click from Courses, choose Principles of Biomedical Science. Left side search bar, Lesson 1.2, Master the Morgue. And we're doing 1.2.4 today, so find 1.2.4 Histology and open that up. All right, so here's our lab journal page again. I'm going to make that bigger so it's easier to see. We will describe the relationship between cells, tissues, organs, and systems in the human body. We will use a microscope to examine and diagnose tissue abnormalities. We can't do that, but we'll look at them and describe the basic anatomy and physiology of the nervous system. Sounds like fun, right? So here is a beautiful picture of the 4 lobes of your brain: frontal, temporal, parietal, and occipital. Now let's click over to our activity 1.2.4. And we'll scroll down. Why are we learning about the brain? Because we are going to look at Anna's brain. See if we can connect something in Anna's brain to the reason she may have died. Okay? So here we go. Histology is the study of microscopic anatomy of tissues. Okay? Here is Anna Garcia's wound on her forehead. Remember, she got hurt at soccer and was self-medicating with aspirin. So read through that. Yep. So to determine whether or not any brain injury occurred, the brain needs to be removed and evaluated. Okay, so that's what we're doing today. So here it is. Update your autopsy report with all relevant information. Okay, so it says record observations the medical examiner made of the wound on Anna's head. We'll come back to that. It says include drawings, but doing things virtually, we can't include drawings. So here we go. We go from the very basic building blocks of cells. Cells working together form a tissue. A bunch of tissues working together form organs. Groups of organs working together make an organ system, like the digestive system, or in this case, the nervous system. Okay? So the nervous system contains the brain, brainstem, spinal cord, and nerves. Okay? The involuntary action of breathing without thinking about it is your brain constantly monitoring your oxygen supply. It's pretty cool, right? So here we go. You can interact with this. You can click on it. Look at that. Spinal cord, nerves, pretty cool. And then you have the CNS and the PNS, central nervous system, the brain and spinal cord, the peripheral nervous system, the nerves. And scrolling down some more, interact with the model below. This is why I scrolled way down. So we have our frontal lobe, responsible for planning and organizing incoming information, controls behavior and emotion. So here we go, over here. Frontal lobe controls emotions and, I can't remember, behavior, responsible for planning and organizing information. Perfect. Now you know. Interestingly enough, when you drink alcohol, which none of you do, but if someday you choose to, one of the first places it affects is the frontal lobe, which controls your emotions and behavior. Interesting. Let's close this one, which is the same tab. Now let's look at our temporal lobe, used for processing language and storing information into long-term memory. So processing language and long-term memory. Cool, right? It's kind of cool to know all these little parts of the brain and what they do. So now let's look at the parietal lobe. Here we go. So in integrating sensory and visual information. Perfect. Sensory and visual information. It's cool, right? And then the occipital lobe, let's see, receives and processes sensory nerve impulses from the eyes. Right. So here's something interesting. The frontal lobe is the last part of the brain to develop, which usually occurs when somebody is 20 or older. Okay. I think I read somewhere that it's around 24 or 25, which means you're basically still children until you're about 24 or 25. Don't get offended. It's just biology. Okay. So how might this affect the people not in your 20s? Right? So the frontal lobe doesn't develop until you're in your 20s. It controls your emotions and behavior. It's responsible for planning and organizing incoming information. Yeah, so somebody not yet in their 20s may have stronger, harder to control emotions, which can lead to, I'm going to say, inappropriate behavior. Oh, thank you, autocorrect. Okay. Something to keep in mind for me with my 7-year-old son, all of his emotions seem big to him, and then to me. And something to keep in mind for all of you. You're not really adults yet. Okay, and I'm going to make this all be on one page because I like it better when it's all on one page. So here we go. Central nervous system. Remember, I named the structures of the central nervous system, but let's scroll back up. The brain and spinal cord. So structure, brain, spinal cord. And the peripheral nervous system, structure, nerves. Let's scroll and see if we can find out the functions. Let's see. Here we go. The brain processes information, makes decisions about what to do, and sends signals back via let's see if we can find it shorter. Nope, I don't think we can. So sad. Okay, so the brain controls all nervous activity. The spinal cord is the main highway for the nerve impulses to travel. The nerves, let's see if I can, I don't know why. Receive sensory input. Just a little too. Haha, there we go. I don't know why I did that, but now I'm happy. So there we go. What might a medical examiner learn by looking at the gross anatomy of the brain? Sure. If the brain was developing properly, their age, that's right. Yes, damage. Yeah, lots of those things. All right, so let's look at a gross examination of Anna's brain. Traumatic brain injury and chronic traumatic encephalopathy. Let's look. We'll scroll down. Traumatic brain injury, a brain dysfunction caused by an outside force to the head. Here we go. I'm going to copy that. I'm going to paste it right there. Chronic traumatic encephalopathy, a progressive degeneration and or death of the nerve cells caused by repeated head injuries, which is a reason I get real nervous about my kids wanting to play any type of contact sport. I mean, I would never say no, but I would be nervous the whole time. High functioning anxiety for you. All right. So if we look at, we have some pictures here, an MRI of a normal brain and the cross section of that same brain. Looks nice. Scroll down, we can see MRI of a traumatic brain injury and a cross section of that same brain. You can see that's a pretty obvious one there. And chronic traumatic encephalopathy, look at that one. That is interesting. It looks like parts of the brain are just missing. That's crazy. And here's Anna's MRI and cross section. So which one of those does Anna's brain show? Is it normal? Does it show traumatic brain injury or chronic traumatic encephalopathy? You're right. It appears to show traumatic brain injury. Yeah, TBI. So here we go. We're going to look at microscopic views right now of normal brain tissue, TBI brain tissue, and CTE brain tissue. So here's the normal stuff. Okay, if you could look at it under a microscope, magnified 40 times, that's actually 400 because the eyepiece magnifies 10. Here is TBI. Look at that. Yikes. I would say all that stuff right here might be fluid in the brain. And if we look Oh, we just see the normal and the TBI. Okay, so keep that in mind, and let's look at Anna's brain. Let's see if our gross examination matches our microscopic examination. Oh yeah, look at that. That looks almost exactly like this. So her brain does show signs of TBI. Anna died of traumatic brain injury. Now we know. You know how Anna died. And we will update Anna's autopsy report in a later episode of Are You Still Awake? All right. So, given what you have learned about the brain structure and function, how might an individual lose their sight or hearing but not have direct damage to their eyes or their ears? Yes, there could be brain damage to the part of the brain that controls. I'm just going to say sight or hearing, but you should know that that's like sensory input. And in medical interventions, you'll learn all about hearing loss, both related to physically listening to things too loudly and in the part of the brain. So explain how a patient's neurological symptoms may give an indication of where a brain injury occurred. Neurological symptoms are what they're presenting with. So again, guys, remember, different parts of the brain control different sensory information. So if somebody was presenting with long-term memory loss or short-term memory loss, the first part of the brain somebody would probably look at is the part of the brain that controls memory, or the temporal lobe. Okay? If they came in presenting with extremely erratic behavior, they'd probably look at the frontal lobe. So you see, knowing a little bit more about the brain will help you become better healthcare professionals. All right. So the second thing in this same assignment day is the tissue types. So if you open this up, the first chart is done for you. Just use Google. Okay, use the internet to fill in the charts below. There's 4 charts total. The first one is done for you. Okay, so you tell me, let's see. Here's the epithelial system. Tell me what the name of the cells are, the tissues that come together, the main organ, and the organ system. Okay, the same with muscles, and I included microscopic pictures, and connective tissue. Okay, just use the internet to look these up, and you have, see, with the nervous system, it just gives one organ, okay, and then the organ system is going to be here, and you list all of the organs in the organ system. If you have any issues with that, just let me know and I'll help you. All right, thank you.